Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of limits. So as per the problem, a circular oil spill on the surface of the ocean spreads outward, and we have to find the approximate rate of change in the area of the oil slick with respect to its radius when the radius is 100 meters. Now the tricky thing about this problem is that we are not given an equation or a function that we can use to calculate the rate of change in the area of the oil slick. So the first step here is to come up with an equation that we can use to calculate the rate of change. Now we have to calculate the rate of change for the area of the oil slick, and as per the problem, the oil spill is circular. So that means we can use the area formula as the function for this problem. So the first step is to write the area function, and for a circle the formula can be written as A at r equals pi r squared. So we know this is the formula for area of a circle. So here r is the input variable, so that's why in the function notation it's A at r. Now we have to find the rate of change with respect to radius when the radius is 100 meters. So the formula for rate of change is limit h approaches 0. So A at r plus h minus A at r over h. We have to calculate the rate of change at radius equals 100 meters. So we have to use the r value as 100 in this setup. This is the difference quotient setup to calculate the rate of change. Now we have to find the expressions for A at r plus h and A at r equals 100. So A at 100 will be equal to pi times 100 squared, which will be equal to 10,000 pi. A at 100 plus h will be equal to pi times 100 plus h squared. And we can simplify this expression. So first we can expand the square. So we get A at 100 plus h equals pi times 100 plus h times 100 plus h. And now we can simplify this expression. So first we can distribute the terms using the FOIL method. So we do 100 times 100, then 100 times h, and then h times 100, and then h times h. So we get pi times 10,000 plus 100h plus 100h plus h squared. Now we can combine the like terms. So we get pi, and in the parentheses we get 10,000 plus 200h. So 100h plus 100h is equal to 200h. So this is the expression for A at 100 plus h. So now we can use the expression that we wrote. So first we can sub in r as 100. So it's basically A at 100 plus h minus A at 100 over h. Now we can sub in the expression. So limit h approaches 0. A at 100 plus h is pi times 10,000 plus 200 h plus h squared minus, and A at 100 is 10,000 pi over h. Now we have to simplify the numerator. So we can distribute the pi into the parentheses. So we get limit h approaches 0. So it will be 10,000 pi plus 200 h pi plus pi h square minus 10,000 pi over h. Now we can combine like terms, so we can cancel out 10,000 pi and minus 10,000 pi. We are left with limit h approaches 0. So it will be 200 h pi plus pi h square over h. Now we cannot apply the limit because there is h in the denominator. So if we sub in h as 0, the denominator becomes 0 and the expression will become undefined. So we should factor out an h from the numerator. So 200 pi plus pi h over h. Now we can cancel out the h's and apply the limit. So now we can sub in h as 0 plus pi times 0, which is equal to 200 pi. So this is the rate of change for the area of the oil slick, and the unit will be meter square per meter. Because we have to calculate the rate of change for the area, and for that the unit will be meter square, and with respect to the radius, and for that the unit will be meter. So this should be the final answer for the rate of change of the area. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.